What are the logical operators we have? The logical operators are logical AND, logical OR, and logical NOT. Right? Where you can use these logical operators? Where we can use this logical operator. The logical operators are used in between. Where you can use the logical operator means these operators are used in between two relational expressions. The logical operators are used always in between the two relational expressions. What are the logical operators? Suppose logical and logical, that is a pipe symbol, and then NOT symbol. Where you can using these operators means there is a two relations. Suppose if A is a greater than B, right, and suppose A is greater than C, in between I have to use the logical operator. Suppose if C equal to A greater than B, logical and A greater than C. If both are true means then you can assign the some value to the C. Now first of all, what is meant by logical and? Suppose we can take A and B are the two inputs. We can take A and B are the two inputs. Now what are the possible combinations? Either A is 0 or B is 0. Otherwise A is 0, B is 1. Otherwise A is 1, B is 0. Otherwise A is 1, B is 1. These are the possible combinations, right? Now in between we have to apply A logical and B. A logical and B, right? Now what is the result? Same as A logical or B. A logical or B. What is the output you have to get? See. Now if you have the two inputs, A is 0, B is 0. Now what is the logical AND means? We can get output is 0. How means? When both the inputs means A is a one input, B is a one input. When the both inputs are low is nothing but 0, high is nothing but 1, right? When the both inputs are low, 0 for the AND one. Otherwise we can say simply when both the inputs are high, both the inputs, that means A is a 1, B is a 1, then result is 1, otherwise 0. That means in logical AND any one is 0. Any one means either A input is 0 or B input is 0. Then we can get the output is 0. Otherwise 1. Or what is another word? Means when the both inputs are high, then result is high. Otherwise 0. That is for logical AND. And next, what is meant by logical OR? The logical OR is nothing but when both the inputs are 0, then output is 0. Otherwise 1. Or what is another statement? If any one output is high, suppose here B is high, here A is high, here both are high, then we can get the output is high, otherwise 0. This is the truth table for logical AND and logical OR gate. This is a gate truth table, right? Based on this truth table, here we have to implementing the logics, right? If A and B is the two input, whenever you can take the two inputs means what is the possible combinations? Either A is value 0, B value 0. Otherwise A value 0, B value is 1. Otherwise A value is a 1, B value is a 0. Otherwise A value is a 1, B value is 1. Based on these input combinations, if we can apply logical AND. What is meant by logical AND means when both inputs are high, then result is high. Otherwise 0. Same as in logical OR. When both inputs are low, that means 0, we can get the output is 0. Otherwise, we can output is a 1. There is a truth table for logical AND and logical OR. Now, based on that, here I have to write the one expression C equal to A greater than B, logical AND A greater than C. Suppose here I have to assume the A value is a 5, B value is a 9, suppose C value is the 6. Right? Now, A greater than B. What is the A value? 5 is greater than, what is the B value? Suppose 9. 5 greater than 9 and logical AND. What is the A value? 5 greater than 6. Now see, 5 greater than 9, true or false? It is a false. And 5 greater than 6, it's also false. Both are false. Both are false. Where in AND gate, what is the result? 0. That is the value of C. That means the result of any logical expression, the result of any logical expression is also a Boolean value. That means the result of any logical expression also a Boolean value. That means the result also in the form of zeros or 1. That is true or false. Are you clear how we can implementing the logical operator? Means the logical operators are used always in between the two relational expressions. Suppose I will explain the one more example. Suppose I can take, suppose A value is a 6, B value is a 4, suppose C value is the 9, right? See, I will write down expression. Suppose C equal to A greater than B, right? Logical and, okay. Now A greater than C. Now see here, A greater than B. What is the A value? A value is a 6. 6 greater than 4. Now is it true or false? The result is 1. Why? Because it is a relational expression. And A greater than C. What is the A value? 6. 6 greater than 9. It is a false. 1 0. 1 0. In logical and what is the output you can get? 0. Suppose instead of logical and, if I can using logical or, here what is the output? 1, here 0. 1 0 in logical or we can get the output as a 1. Suppose if it is a logical or means the output is 0. If it is a logical or means output is 1. Suppose where you can using the logical not. Suppose in the same expression. Here I can take the two value. Suppose A equal to 6, B equal to 7. Suppose C equal to A greater than B. Now what is the result? What is the result? Means 6 greater than 7. True or false? False. Actually the result is 0. Now we can using the logical not. You can using logical not. Means not of 0 means we can get the output as a 1. That means the complement value. Not is nothing but you can using here the complement value. Are you clear? What is meant by logical operator? Where you can use means the logical operators are logical and logical or and then logical not. These operators are used in between the two relational expression, and the result of the any logical operator is also Boolean value. That means it gives the result in the form of 0 or 1. The result true or false. Right? These are all the logical operators. Right? Then next one is bitwise operators. Very, very important how we can implementing the bitwise operators. Bitwise operators. Then where you can use the bitwise operators? Where we can use the bitwise operators? The bitwise operators are used whenever you can perform. Whenever we can perform an operation in bit by bit position. We can perform the operation on bit by bit position. Right? Whenever you can perform an operation, we can an operation by bit position, then you can using the bitwise operators. Now what are the bitwise operators we have? The bitwise operators are bitwise and. The bitwise operators are bitwise and, bitwise or, bitwise exclusive or XOR, then right shift and left shift. Right? Now what is a bitwise and operator? Means only one ampersand, one pipe symbol, cap symbol, angular symbol right towards the right direction, and then left shift. These are all the operators we are using the bitwise operators. Now I will explain one by one for each example. First, bitwise and. What is mean bitwise and means? Suppose I will explain one example. Suppose I can take A value is a 4, B value is a 3. Right? Now C equal to A bitwise and B. Now what is the output for C? Means here how we can perform the bitwise operation means, if we can take the A means, what is the binary value for A? That is the 4. What is the binary value for? 0 1 0 0. Same as for binary value for 3, 0 0 1 1. Okay, this is the binary value for 3. Now in between, what is the between bits we have? Binary value for A is 0 1 0 0. For B, binary value is 0 0 1 1. Means in between we have to using the logical AND. Logical AND means bitwise AND we have to use. Bitwise AND also means 0 1 in logical AND we can get the output as 0, right? 0 1 in logical AND we can get the output as 0, and 1 0 in logical AND 0. 0 0 is also 0. That means the output is 0 for when you can using the A logical AND, bitwise AND B. Suppose for the same expression, if you can use A bitwise or B, means instead of here we can using bitwise OR gate. What is the OR gate truth table? When any one value is a 1, we can get the output as a 1. For that one, suppose if it is the logical AND means the output is this one. Suppose if you can using logical OR, 1 0 1 means the output is 1, 0 1 means 1, 1 0 means 1, 0 0 means 0. That means equivalent decimal value is 0, equivalent decimal value is 7. Now for this one the output is 7, for this one output is 0. Are you clear? Means by bit position we have to applying the truth table. Same as if we can using exclusive OR. Now what is the truth table for exclusive OR? If we can take two inputs, suppose A is a 0 B 0, A 0 B 1, A 1 B 0, A 1 B 1. In between, if we can using A exclusive OR of B, what is the truth table? Means here when both the inputs are same, when both inputs means that is the A input and B inputs are same is nothing but either 0 0 or 1 1, then the output is 0, otherwise 1. Clear? When both the inputs are same 0 0 1 1, then I can say the output is 0, otherwise the output is 1. Clear? Now based on that, here you can see for the same input combinations, right? If we can assume what is the output? 0 1 means alternate outputs, we can get the output as 1, alternate 1, alternate 1. Now same input 0 0 means 0. That means for this one also we can get the output of A exclusive OR of B is nothing but we can get the output is a 7. Are you clear? How we can implementing the bitwise operators means bitwise and bitwise OR means we can performing the operation a bit by bit position based on the truth table of logical AND gate, logical OR gate as well as exclusive OR gate. Based on those truth table we can apply the bit by bit position. Clear? And we can see what is meant by right shift, what is meant by left shift. Right? Now we can see the right shift and left shift operators. The next one is right shift. This is the operator, this one, right? First of all, what is meant by right shift? Right shift is nothing but we have to move or you have to shift, right? We have to shift, okay, now a 1 bit information, towards right direction, is called as a right shift. Means if we can take the any value, that value a 1 bit information we have to move towards the right direction, then we can using the right shift. Suppose for example I will take the one example. Suppose I can take C equal to suppose 5 is right shift of 2. Here what is the meaning means? Here 5 is nothing but the value of 5 we have to move. How many shifts you want to perform? 2 shifts. Which direction? Towards the right direction. Means it can represent number of shifts. This will be represent the value. What is the which value you want to represent? The value of 5. I want to shift which direction? Towards the right direction. How many shifts means two shifts, right? Then how we can move? Actually, if we can assign the value, suppose for example, if I can assign a equal to 5, then how this value will be stored actually in your computer means it will be stored either 16 bits or 32 bits. Suppose 0 to 15, it is a 16 bits means. Now what is the binary value for 5? The binary value for 5 is actual bit position is 101. 101. Remaining all values, what are the rest of values? 16 bit positions. All the values are zeros. In this order, what are the values you can store? All values will be stored in either the 16-bit information or 32-bit information. Like that it will be stored. Now, here the shifting is nothing but what is the stored value in the form of binary. That is a system format. These shift format values will be shifted towards to the right direction. Now, how many shifts you want to move? I will explain simply by the simple value. Now, what is the input? 5. What is the binary value for 5? Binary value for 5 is 0, 1, 0, 1. Just I will take the only 4 bits instead of taking the 16 bits. That is a confusion. Now, here I have to performing the shift 1. What is meant by shift 1? In which direction I want to shift? I want to shift towards right direction. Suppose it is the right direction, it is the left direction. Right? Now I want to move, means it is the bit position. Right? It is the bit position. I have to store, suppose 0, 1, 2, that is the position you have to represent. Now the 0th bit position will be whenever you can move towards the right direction, means this bit will be comes to the outside. Once it will be comes to the outside, now what will happen? Suppose the same 4 bit, right? Suppose here 1 will become, this will be comes to the outside, means here we can get the empty position. Now what is the value here? 0, 1, 0. That is the actual, means the 1 will be comes to the out. Now in this empty place, what is the previous value? That is a 0 will be comes to the here. This next value will be comes to the here. This value will be comes to the here. If we comes like that, now what is the next result we can get? Here we can get 0, here 1, here 0. Now here you can get the empty place, right? In this empty place, we can fill with 0. We can fill with 0. That means finally now what is the next output we can get? After the one shift, we can get the value is 0, 1, 0. We can fill with the 0 means 0, right? There is the end. Means for the first shift, what is the output we can get? 0, 0, 1, 0. What is the actual input? 0, 1, 0, 1. Means we can perform the one shift towards the right direction. Means the 1 will be comes to the outside. Then in this place, the previous value will be replaced. For this shift 1, what is the shift 1 result? This one. Suppose again we can perform the next shift. We can now shift to which bit? This bit. Now this 0 will be comes to the outside. Now what will happen? Now this 1 will be comes to the here. This 0 will be comes to the in this position, and this position this 0 will become. Now here there is a empty place, right? In this empty place we can fill with the 0. We can fill with the 0, right? Now what is the value here? 0. Here also 0. Now here we can get the output as 1. Now what is the final? 0, 0, 0, 1. What is the equivalent decimal value? That is the 1. That means if we can move towards the 5 into the right direction, how many shifts means? 2 shift means. Now what is the value of C is 1. Are you understood? Suppose for the one shift, suppose if I can perform the one shift means what is the output? For the one shift, this is the result, right? 0, 0, 1, 0. 0, 0, 1, 0 means what is the output? 2. For this one, output is a 2. If it is a 2 shifts means the output is the 1. Otherwise, there is a one simple formula is, suppose if we can assume it is A, it is the B. That means C equal to A, right shift of B means we can use the formula C equal to A by B square. A by B square. What is the A value? A value is a 5 by 2 square. That means 5 by 4. 5 by 4 means what is the value? 1 point something. Means point we have neglect means what is the value you can get? That is the 1. Suppose when if it is a 2 means that is 5 right shift of 2. Suppose right shift of 1 means we can see 5 by 1 square. 5 by 1 square. Sorry. Right? Are you clear? How it will be shifting towards to the right direction. The same we can move towards the left direction. Towards the left direction. Suppose C is 5 towards the left direction. What is the binary value for this one? For 5, binary value for 5 is 0, 1, 0, 1. That is the positions we have to represent. Now we have to move towards the left direction. If we can move means this 0 will be comes to the outside. Right? Now in this place this 1 will become, in this place this 1 will become, in this place this 1 become. Now here we can get the one empty place. This empty place is filled by the again 0. Now what is the output you can get? Here 1 means this 1 will be comes to the here. Now this 0 will be comes to the here. This 1 will be comes to the here. For this empty place we can fill it with the 0. This is the output for first shift towards the left directions. Means what is the value? 1 0 1 0 means we can get the output as a 10. Right? Suppose if you have to perform that one more shift, then again this 1 will be comes to the out. Now in this place we can place with the 0. Here we can place with the 1. Here we can place with the 0. Right? Again there is an empty place. That empty place is filled by the 0. Now what is the equivalent value for the decimal means 4. That means if we can move the 5 is say 2 shifts towards the left direction means we can get the output as 4. Clear? That is called as right shift and left shift. Left shift means we have to shift a 1 bit information towards the left direction. Towards the left direction. Are you clear? I think all of you clear about what is meant by shifting operations.